Hello everyone. Today we're going to go over another example of solving systems of equations by elimination. So, let's get started. Here's our first question. We have two equations, and we want to solve them by elimination. Try this by yourself first, and then we'll go over it. Okay, now, remember, to solve using elimination, we choose one of the variables, and then we either multiply or divide the equation by a constant so that the coefficients for the variable in both equations are the same. So here we could choose x. That would mean we have to multiply equation 1 times 2 and equation 2 times 7, which would give us a coefficient of 14 minus 14x and 14x. But an easier variable here to choose would be y. If we chose y, then we could leave equation 1 as it is, and we just multiply equation 2 times 2, which would give us 20y plus 8 is equal to 4x. And now our coefficients have the same magnitude. Now, we could subtract the equations from each other like this, or add or subtract, but it'll make more sense if we manipulate our terms a little bit. So let's bring the y's over to the same side. That gives us 20y minus 14 is equal to minus 7x. For equation 1, and for equation 2, 20y plus 8 is equal to 4x. So if we add those together, or we want to subtract them, if we subtract them, we get minus 22 is equal to minus 11x, so x is equal to 2. When we plug that back in to one of our earlier equations, say 10y plus 4 is equal to 2 times 2. That's 10y plus 4 is equal to 4. Subtract 4 from both sides. And we have 10y is equal to 0. So y must be equal to 0 at the point where these two equations meet. So our answer is 2, 0. Let's try another problem. Try this by yourself, and then we'll go over it. Okay. Now, we have an x coefficient of 2 in the first equation, and of 10 in the second equation, and a y coefficient of minus 1 in the first equation, and minus 7 in the second equation. So we can see right away that the easiest way to get the coefficients to equal each other would be to choose variable y and multiply the first equation by 5. So that gives us 15 plus 10x minus 5y is equal to 0. And we leave the second equation as it is. Minus 3 minus 7y is equal to 10x. And actually, we can move around the terms in the first equation a bit just to make this clear. If we move x to this side, we get 15 minus 5y is equal to minus 10x. So now, if we want to get 0, if we want to eliminate x, we have to add the two equations to each other. So that gives us 15 minus 5y minus 3 minus 7y is equal to minus 10x over 10x. Actually, since this is negative and we want to get x is 0, we should add them. So minus 10x plus 10x is 0. 15 minus 3 is 12. minus 5 minus 7y is minus 12y. So we have 12 is equal to 12y, y is equal to 1. And plugging that back in, we get minus 3 minus 7 times 1 is equal to 10x, minus 10 is equal to 10x. So x must be equal to negative 1. So our answer is xy is 1, 1, or minus 1, 1. And if we want to double check that, we can put it back into our first equation. 3 plus 2 times minus 1 minus 1 is equal to 0. 3 minus 2 minus 1 is equal to 0. That's correct. We found the right answer.